Download this code from codegive.com, link in the description below. Achieving a 1000x faster performance in JavaScript is an ambitious goal, but there are numerous strategies and techniques you can employ to significantly improve the performance of your JavaScript code. Here's a comprehensive tutorial covering several optimization techniques, along with code examples to illustrate each strategy. 1. Use efficient algorithms and data structures. The choice of algorithms and data structures can have a huge impact on performance. For example, using a hash table, object, for lookups is generally faster than using an array for searching. JavaScript. / inefficient search in an array. Function find index in array, ARR, value. Return ARR index of, value, / o, n. / efficient search using an object. Function create lookup, ARR. Const lookup equals ARR for each item, index, equals lookup item equals index. Return lookup. Const lookup equals create lookup, apple, banana, orange. Console.log, lookup banana, / o, 1. To avoid unnecessary computations. Memoization is a technique that stores the results of expensive function calls and returns the cached result when the same inputs occur again. JavaScript. Function memoized Fibonacci. Const cache equals. Return function fib, n. If, n in cache. Return cache n. If, n equals 1, return n. Cache n equals fib, n, 1, plus fib, n, 2. Return cache n. Const fib equals memoized Fibonacci. Console.log, fib, 40, / much faster than naive recursion. 3. Minimize DOM manipulations. Interacting with the DOM is slow, so reduce the number of manipulations by batching updates. JavaScript. Const items equals item 1, item 2, item 3. Const list equals document.create element, ul. Items. For each item equals. Const li equals document.create element, li. Li text content equals item. List.append child, li. Document.body.append child, list, / batch updates. 4. Use web workers for parallel processing. Web workers allow you to run scripts in background threads, freeing up the main thread for user interactions. JavaScript. / worker.js. Self.onMessage equals function, e. Const result equals e.data.map, x equals x * x, / expensive computation. Self.postMessage, result. / main.js. Const worker equals new worker, worker.js. Worker.onMessage equals function, e. Console.log, result from worker, e.data. Worker.postMessage, 1, 2, 3, 4, 5. 5. Leverage asynchronous programming. Use async / await to handle asynchronous operations effectively without blocking the main thread. JavaScript. Async function fetch data. Const response equals await fetch, https://api.example.com/data. Const data equals await response.json. Console.log, data. Fetch data. 6. Reduce scope lookups. Accessing variables closer in scope is faster than traversing up the scope chain, so minimize the use of global variables. JavaScript. Function outer function. Const local var equals I am local. Function inner function. Accessing local var is faster than accessing a global variable. Console.log, local var. Inner function. Outer function. 7. Use lazy loading. Lazy loading defers the loading of resources until they are needed, thereby speeding up the initial load time. JavaScript. / lazy loading an image. Const img equals document.createElement, img. img.src equals path /to /image.jpg, / load only when needed. img.onload equals. Document.body.append child, img. 8. Optimize loops. Use the most efficient way to iterate over arrays and avoid unnecessary iterations. JavaScript. Const arr equals new array, 1,000,000, .fill, 0. Let sum equals 0. / using a traditional for loop. 4. Let I equals 0, IARR length, I++. Sum plus equals ARRI. / using for each, less efficient. ARR for each, number equals. Sum plus equals number. 9. Minify and bundle your code. Use tools like Webpack or Rollup to bundle your JavaScript code and minimize file sizes. This reduces load times. Conclusion. While achieving a literal 1000x speedup might not be feasible in every case, using these techniques can lead to substantial improvements. The key is to understand where your bottlenecks lie and apply the right strategies for your specific situation. Always remember to profile your code to identify the areas that need the most optimization. Tools for profiling. Chrome DevTools, use the Performance tab to analyze runtime performance. Lighthouse, audits your web application and provides optimization suggestions. Web Page Test, tests the speed of your web page from different locations and browsers. By implementing these strategies, you can make significant improvements in your JavaScript performance, enhancing the overall user experience.